Today we are given this question and we are required to find the value of a, density function of x, density function of y, f x of y given f x given y, f y given x, expected value of x, expected value of y, expected value of exy, expected value of y given x, and expected value of x given y. So first we are given that the joint density function of fxy is ay square in the given range y greater than 0, less than mod x, less than 1, and elsewhere it is 0. Now we would find the value of a. To find the value of a, we know that the area under the curve of joint density function is 1. So for that, this is the equation for that. And now putting the values and the limits, we would get minus 1 to 1, 0 to mod x, a y square dy dx equal to 1. Now we would first integrate with respect to y dy and taking the constant out of the integration, so it would become a minus 1 to 1 y cube upon 3, 0 to mod x dx equal to 1. On putting the values and solving, we would get a limit minus 1 to 1 mod x cube divided by 3 dx equal to 1. Now on as it is an even function, because whatever values goes inside mod x, it would only positive value would come out, so we can remove the mod and we will break the limit from minus 1 to 0 and 0 to 1. So on combining these two steps, I would get a, that is 2a for breaking the limits, 0 to 1 mod x cube upon 3 dx equal to 1. Rather, we can take this constant outside. So this would be 2 by 3a x cube integration 0 to 1 with respect to dx equal to 1. On doing this and solving, we would get 2a by 3 x raised to the power 4 divided by 4, value from 0 to 1, that is equal to 1. So this would be 2a by 3 1 by 4 minus 0 equal to 1. So on solving, we get the value of a as 12 by 2, so this is equal to 6. So we get the value of a is as 6. Now we can again write the joint density function as, by replacing the value of a, that is 6 y square in the given limit and 0 otherwise. Now we will find the density function of fx. So this is equal to, that is integrating the joint density function with respect to y. So putting the values, we are getting a limit 0 to mod x 6 y square dy. So on solving, on integrating, we get 6 y cube divided by 3 from 0 to mod x. So on putting the values, we will get 2 mod x cube, where x is greater than minus 1 and less than 1, and y belongs in the range less than mod x less than 1. So we get the density function of f of x, that is f of x is equal to 2 mod x in the range. Now we will find the density function of y, that is fy of y. It is integrating the joint density function of x and y with respect to x. So putting the values of the limits and solving, minus 1 to 1 6 y square dx. So now here we will break the limit, as the limit is from minus 1 to 1. We will break it using it y point, break point y, so that minus 1 to minus y and from y to 1. This would be minus 1 to minus y 6 y square dx plus integration y to 1 6 y square dx. Now as both these terms are constant, we can take them outside the integral. So that would be 6y square minus 1 to minus y dx plus 6y square y to 1 dx. Now on solving and putting the values, we would get minus 12 y cube plus 12 y square. So taking 12 y square common, we would get 1 minus y, and the range is from y greater than 0 less than 1. So we get density function of y is 12y square 1 minus y 0 greater than y less than 1. Now we would find that is f density of x given y, is f x upon y. So this is equal to simply divide the given joint density function with respect to f value of y. So putting the values, we get 6y square upon 12y square 1 minus y. Cancelling out the common factors, we would get 1 upon 2 1 minus y, and the limit is from y greater than 0 less than mod x less than 1. Now we would find, so we can put the values there. So that would be f, x upon y. So this is 1 upon 2 1 minus y in the range. Now we are finding y given x. So that would be equal to, again, the joint density function of fx and y divided by the density function of fx of x. So this is equal to 6y square 2 mod x cube. On solving, we get 3y square upon mod x cube. That would be 0 y greater than 0 less than mod x in the limit range. So we get the value of f y by x, that is value of y given x, that is 3y square divided by 2 mod x cube in the limit range of 0 mod x. Now we are required to find the expected value of x. So this is minus infinite to infinite. The formula is multiply x with the density function of x and integrate with respect to x. So putting the value limit minus 1 to 1 x multiplied with 2 mod x cube, that is value of the density function of x, and integrating with respect to dx. Now again, on breaking on removing the mode function as any value either positive or negative which enters the mode, the outcome would be positive, and on breaking the limits, we would get minus 1 to 0 to x4 dx 0 to 1 to x4 dx. On solving this, we get the value as 0. So the expected value of x is 0. Now expected value of y, it would be integrating, that is multiply y with the density function of y and integrate it with respect to y. So here y into 12 y square 1 minus y divided 0 to 1. On taking the common out and on solving common out, we would get, and multiplying y with this term, we get y cube minus y4 integration with respect to dy. So, and on solving this, we would get the values as 12 by 20. So this is on simplification 3 upon 5. So the density function, so the expected value of y is 3 upon 5. Now we will find the expected value of exy. This is nothing but integrating, first multiply xy with a joint density function of fxy and integrate with respect to dxy. So I'm putting the limits -1 to 1 u to mod x xy 6y square dx dy. Now we'll first integrate with respect to dy, so we'll write dy here and dx here. On integrating, we will get -1 to 1 -1 to 1 x 6 mod x to the power 4 and dx. That is, we will integrate with respect to dy, and on putting these limits after the integration, we will get this value. Now we will multiply this, the term that we got after integrating with respect to dy with x, and then integrated with respect to dx, and on solving we would get the answer is 0. So again, expected value of x of y is 0. Now we are required to find e y of small x. It is same as e y given capital X, and it is integration minus infinite to infinite y, that is multiply y with f density of y given x and integration with respect to dy. It is placing the limits 0 to mod x y, putting this value of here, we get 3y cube upon mod x cube, 3y square upon mod x cube, and also, and on integrating and solving we would get 3 mod x upon 4. So the value, expected value of y given x is 3 mod x upon 4. Now we will find the expected value of x given y. This is again minus infinite to infinite, multiply x with the given value of fx of y, integrate with respect to dx. Putting the limits, that would be -1 to 1 x into fx of y is 1 upon 2 1 minus y dx. That is, again we will break the limits at the break point y, and we will solve it. So I am breaking the limits and writing y to y x to 1 minus y dy plus y to 1 x divided by 2 1 minus y dy. Now on integrating and solving, and that is putting these values, we would get exy as 0 as well. So again ex of y is 0 as well. Now after that is, we have got the value of a, that is 6, density function of x is 2 mod x cube, density function of y is 12 y square 1 minus y, and these are the ranges for them, and the density function of x given y is 1 upon 2 1 minus y, and the density function of y given x is 3y square upon 2 mod x cube, and this is the range for it, and the expected values of x is 0, y is 3 by 5, exy 0, ey by x 3, mod x by 4, and ex upon y, ex given y, that is 0. And we are also required to draw the plots for density function of x by x given y and y given x. So first of all, we would draw the graph for fx, that is, we will draw the graph of x, that is fx of x. We are given the values 2 mod x cube, and the range is, as we can see, the range is from 0 y to 1. So we can plot it simply here, that is the x cube, and its value range varies from -1 to, that is the limiting range is -1 to 1. Now on plotting fy of y, we know that fy of y is 12 y square into 1 minus y, and the range is from y greater than 0 less than 1. And it would end on solving by using maximum and minimum method, we will get a maximum at 2 by 3, so which I have directly plotted here. We can solve it using simple differentiation to get the maximum and minimum value points. Now we are also required to plot f density of y given x and density of x given y. For density of y given x, we know that this is equal to 3y square upon 2 mod x cube, and the range of y is y greater than 0 less than mod x. So we can plot it here. And this dotted portion represents that the value may extend up till there. For the given density, now we are plotting the last density, that is the density of x given y. And this is here 1 upon 2 into 1 minus y, and the range is given here. We can plot it in this way. Thank you.